Hello and welcome back to a Common Lisp tutorial video. I do apologise about the delay. Obviously we had the winter break and well, COVID hasn't gotten any better, so it's just been a wee bit of a time, and I'm sure many of you will appreciate in your own lives how hard it can be, so I hope you are all well, and I hope you're ready for a new video. I'm going to try out a new bit of video recording software. We're going to see if that works. It seems to, but I just want to, if it doesn't work for this video as well as the previous method, we'll go back to that. But we left off last time looking at the Common Lisp object system, CLOS. Let's, get a file open here. I've got OP3. That's what we were going to start looking at, and there we go. We don't have anything here yet, and that's okay. What we have seen previously is structs, and we had a little look at classes, and we didn't look at methods in that because, well, Common Lisp does it quite differently, and it's kind of cool. It takes a little bit of getting your head around, but when that happened, I really did kind of like have an aha moment where I suppose there's no easy way to begin, but what happens if your methods are completely disconnected from your classes? It sounds a bit odd, but let's start by seeing how that works. We are just going to start with creating a method, and that might sound really weird, but that's what we're going to do. Def method, and we're going to say hi thing, right? Now, a method doesn't do anything on its own. Right. So a method just tells us what, in an abstract sense, this thing is going to do. And I am suddenly realizing I might have got this the wrong way around. I have got this the wrong way around. There we go. We define this thing called a generic function. Now we overload these generic functions with methods. And the way we have to do that evaluate this. I got that the wrong way around. That's other languages telling me that the type goes first rather than the object. So we have a generic called hi, a def generic, and that takes an argument. We must have the argument match, so we've got this argument called thing here. It has to match here, and what we do is we specify what data type is going to be passed into the function, and we have this hi method here. So if I do this, hi NMunro, we get string NMunro, but if I do this, I get an error because I don't have a method that operates on a number, but that's okay. Now we have to have the argument match. sorry, numbers. I've been programming in JavaScript all day. You know, that doesn't have a distinction between an integer and a float class. So there we go. Right. So we've got our high method that is taking the thing, and it is specializing on an integer, and we can do this now. We get integer 5 in the bottom left, and you know, high thing, we get string thing. So in this way, we are able to write methods that specialize on data types, and it is very, very strange, or I certainly found it very strange when, you know, we were able to just plug methods into things. And this has an interesting implication, because when we're specializing on these things, and something to bear in mind, oops. So I'm just going to recompile these. Don't know what went wrong there. Let's just that. You know, I'm just going to restart my interpreter there. Just stop it completely. So we're defining our generic function again. There we go. So you can see here that we can still pass extra arguments in, but we could also specialize on this too. There we go. Sorry, losing my mind there. So if we evaluate this, we get string 5, 4, and 3. We get string thing 4 and 3. So we can specialize on these types as well. So you can have as many or as few specialized types on these methods, and these can be untyped. So you can build lots of small specialized functions and specializing only on the arguments that you want. And I guess this only really makes sense when we consider that when we looked at classes and structures as well, they don't just build a class and then the mechanisms to build an instance of a class. What it does is it builds a dedicated type of the class that you are creating. So if we went to def class here, accessor. So we've got our person class here, and we will say thing there we go. And we'll just get rid of these extra arguments because we don't need them. There we go, and we'll just get rid of this extra stuff here. Doesn't seem to like it if I am starting again. So let's recompile these now that we're taking a person. Oh, actually, in fact, we only need that. And of course it won't compile because I've not compiled the person class, so it needs the person class compiled for me to compile the high method there. Oh crap, what did I do there? I hit a number of buttons because I wasn't paying attention. Sorry about that, I'll have to take that out again. So we get our person object printed out here. And let's say name person, and we compile that. Oh, whoops. I need the actual variable, not the type. There we go, so this should work now. So we get person NMunro. And so, if we built another thing here, so we've got an animal thing here, and if I just compile that, there we go. And I'm just going to say high P, high A. When we see that evaluated, we've got that animal Fido thing there. So because we are specializing on a type, and because def class creates a type for us, we can now specialize. We can disconnect our methods from our classes. You know, we have methods that do something with a piece of data, and we've got classes that contain data. In fact, in a roundabout way, this is kind of sort of what's happening here, is that a generic method called name will be created when we use accessor, and we create another class that has the same method name, but it is just, you know, a generic thing that is created behind the scenes, and then it just specializes on the types that we're creating as we're creating them. So that is pretty cool. I have never seen anything like this, and I really like it. One of the things I've kind of been working on in my spare time is a unit conversion library. So we'd have like centimeters and meters and things like that. And I just write a def generic convert function, and it just converts one thing from another. And then I just write, you know, methods that specialise on that. And I think really that's the example we want to go for here, now that we've seen a bit of a small play here. So what does a distance have? To be honest, I'm not sure what a generic distance has, but we can compile that. Oh, not in arg, init form, obviously. There we go, so we've got our meter and kilometer, which are distances. Oh, and this is our generic, so we need our documentation. And we'll just compile that. So what would a meter and a kilometer have? Well, for a start, we can say this value init arg value init form 0 accessor value, and do the same for this. Actually, we could take that. That could be in our generic distance thing here. There we go. And so when we're dealing with meters, we could say meter value d. The same here. Kilometer value d. So I'm just going to make sure they're compiled, and then we'll get some code here. For make instance meter. So name is optional, so value is going to be 5. Let me actually specify that. And that's interesting. Ah, there we go. It's because I hadn't recompiled the other one. So we have, a meter and a kilometer display function. And so if we take these, and this is for a kilometer, we get kilometer 5, and I'll just change that so it's a little bit easier to read. So we can tell the difference, meter is 5 and kilometer is 3. Now I am curious about something. And I just want to test my understanding is complete here, because it might not be. There is a thing called call next method, and I know it can be used when you're around certain things, because these methods have before and afters, which again I have never seen in a programming language before, and I think I'm going to leave that for another video, because there's a lot to these methods, and it's going to take more than one video to deal with all of that. It's going to take lots of videos for object orientation in Common Lisp, and that's fine. But what I want to do is, I think I want yes. So a kilometer extends a meter, which extends or inherits from a distance. So now a kilometer is actually a subclass of a meter. So let's put def class yard. I think yard is the imperial thing, because inch and centimeter, and then there's like, what, 16 inches to a yard and 3 yards to... Oh, I don't know. So has a name with an init arg name, init form yard. You know, the imperial measurements are not consistent with one another. They have conversions, but they're not extensions of each other. And it's not the same with meters and kilometers, which obviously extend from one another. So we've got our yard class, and I'm just going to write a method on a yard to make sure that we've covered all of that. Cool. So that's working for yards as well. Now, let's come up with a new generic function, def generic do stuff. I have had a very long week. I am not especially creative on naming things today. So we're going to implement def method do stuff, and this is going to be dmeter. And then we're going to do the same with this. And nope, I might have got myself a wee bit confused there. We would obviously need to have a second parameter to do stuff, and that's okay. Yeah, we'll have a word there. So do stuff takes a meter, takes a word, and all we're doing is that word. There we go. It takes a word there. So let's compile that. I think I know where I'm going with this. I am basically just making this up as I go. So we now have our do stuff. So let's do stuff m, do stuff m, or this should be km, do stuff y. So we run this. Needs at least 2 arguments. That's fine because it does. Meter, kilometer, and yard. Doing stuff with a meter, doing stuff with a meter, and once again I have not specialized. So let's compile that. And let's compile that. Doing stuff with a meter, doing stuff with a kilometer. We don't have one for a yard, but not important to that right now, because what I want to have a look at is this, and I'm really hoping it works. So this works, doing stuff with a meter. There we go. So what we've actually done here is, if you are wanting to, you can actually, if you've got this inheritance going on, where we have, you know, our kilometer is inheriting from our meter, we can obviously, as you've seen earlier in this video, create specialized methods on types. But those types can then call the next most specific method. So when we type our methods, you know, with our kilometer, not typing it out on the keyboard, but we're adding types to our methods and having these methods specialize on combinations of types to arguments, which is cool. It's a bit like method overloading in Java, but more flexible. So we will hit the most specific method that we can, but we can then call the next most specific method with the various arguments and call all of the methods. So if we're wanting to extend behavior on more and more specific classes, we only need to write stuff specific. So we start in our general case and write stuff specific to our general case. Then we write a slightly more specific case, which does something slightly more specific, but then can also call the generalized stuff, and then we can have something more specific than the specific thing, and so on and so on and so on. Just adding in, you know, a new specialized class, a new method for dealing with that, and then we can offload and pass that data back up the method calls to still rely on the existing behavior for generalized stuff, which is really cool. And I do appreciate that I've had moments of stopping and starting with this, and perhaps not having the most consistent plan in my mind. But let's add this in here. Def method do stuff d on a yard takes a word. With that in place, can execute this now, and then we could have a I don't know what comes next. Is that a fathom? It probably isn't, but it doesn't matter, because it's just something that doesn't quite have the same relationship to units as you know, the metric system. So there we go, we've got a fathom, and we've got our yard here. And we're just gonna, whoops, there we go. So we can do this and get our yard and fathom by having, you know, methods that are not calling generalized behavior, because these things, although they kind of sort of have a relationship with one another, they're not consistent between, you know, inches and yards and whatnot. It's feet. I'm thinking of feet, inches to feet to yards. That's it. Yeah, better late than never, I suppose. But where we do have this consistent relationship and we do want objects to then call behavior on stuff, we can use this call next method, function, method, to go up the inheritance chain. So I know it's a brief video. It's only about half an hour long or so. And it just serves as kind of just a gentle introduction to methods, and you know, we're not doing anything too crazy with classes. It's just simple inheritance here and simple methods. But when you are building your classes and you're creating accessors and things like that, you know, these methods are being generated behind the scenes for you, and this is how we can overload these things, because it's not a function that, you know, takes all sorts of different things. The way that the methods are structured here, it allows you to add whatever types in with your classes, but if you're not building classes, you can still use this method dispatch system with the language itself without needing to use classes, because although you might think of Common Lisp as a functional language, and it certainly has that history of, first class functions and you know, sort of paving the way for things like scheme and closure and whatever, Common Lisp itself is actually very, very object orientated as well. You don't have to create your own classes or structures if you don't want to, but you can still take advantage of this method dispatch system and get this really nice hybrid approach of functional stuff with methods, and methods being separate from classes gives you a lot of freedom to do stuff. And I genuinely like this, and it kind of reminds me a little bit of Scala. It, not in any syntax way, but this idea of object and functional programming working side by side. And I don't think the Common Lisp developers especially planned it that way. They just saw good features they wanted to implement in a language and build a general purpose language, but it has incredible power with this. We'll look at all of the, hopefully all of the things that you can do with methods as well, including like the before and the afters and arounds, perhaps in another video where we can just take one or two examples and work on those specifically. We just wanted to kind of get a general feel of what these things are doing and how we might use them, and in the next video we'll look at specifically at maybe one or two class examples and how the before and after and around things work. So I hope that has been interesting. I'm hoping to get back into the flow of things. I'm still backfilling, blogs for previous videos, so do bear with me as I'm, catching up with all this creative stuff and, work as always. I am a teacher in a boot camp, so I'm teaching code and computer science. So sometimes it gets really tiring, and sometimes I'm just a little bit wiped out, but I do enjoy these, so please give me a prod on Twitter or something if you are concerned, and I will let you know when my next video is due to come out. But thank you very much for watching, thank you for following me and encouraging me over the winter break. Have a great week, and I will see you in the next video.